Right, so the diagram below shows two right angles, ABC and ACD. They have right angles at B and D respectively. AB is 10, AC is 12, AD is equal to DC. Okay, interesting. Okay, X and X. The angle BAC is marked Y. Use trig to find the size of the angle Y. Give your answer correct to 1 decimal place. Okay. I'm going to bring this one up here. Oh, didn't like that. Okay, I'll leave it be. Okay. Size of the angle Y. Okay, so there's my Y, there's my 10, there's my 12, and there's my right angle. Okay, and the benefit of being able to draw the diagram like this is that you strip away the story that's around it. So no matter what this story is, whether it's a tree, whether it's a building, whether it's a person, whether it's just a triangle like they give you in this case, you don't care when it comes to solving it, okay? So if you can extract the triangle, the right angle triangle from it, then you get to just concentrate on that, okay? So that's my hypotenuse. There's my angle. So this one is my adjacent because across from the angle is always the opposite side. Silly old Harry caught a heron trawling off America. Okay, and that will be the start of every one of my questions, even now. Even when I'm doing my own trick questions, it'll always have the labeled sides. I will always have this. It is good practice. So Y, I need to find an angle. Okay, so let's see what we have. We have an adjacent and we have hypotenuse. In this case, no point using opposite because I know nothing about it. So that rules out sine, it rules out tan. So the only one that's left is cos. Okay, and I'm not saying that the others wouldn't have given me the answer, but I would have had needed to know what the opposite side was to be able to use them. So we're getting cos of the angle being equal to adjacent over hypotenuse, okay? Or for our question, cos y is equal to 10 over 12, okay? Opposite of cos is cos inverse. Cos and cos inverse cancel, so that you're left with just y being equal to the cos inverse of 10 over 12. Pop onto your calculator, go to cos inverse, which sits behind cos, hit your fraction button, 10 over 12. And I am getting 33.5573 degrees. And you can see I always write down loads of decimal places and then I round it. And the reason I do that is so that I don't lose any marks for having the wrong answer. That is the right answer. If I mess up my rounding, then take the marks away for rounding. But don't take the marks away from me because I got the right answer. I just rounded it wrong. So 1 decimal place. So you have to look at the second part. 5 or greater means I add on 1 to the number before. It's 33.6 degrees. So that's the first part. Now the second part, find the value of x, okay? So in this one, I am going to draw the other triangle, okay? My right angle is up here. I have x and x and 12. And I don't have any other information in that other triangle. So the fact that y is down here and the fact that this is 10 and the fact that I now know this is 33.6 degrees, none of that actually helps me. Okay, all that's relevant to finding x is the triangle that the x is in. Okay, if I knew that that entire thing was, for example, a right angle, then maybe I could use the 33.6 degrees then, because 90 minus 33 would give me that. But I don't know, and nobody told me that was a right angle, so I can't assume that. So no information from ABC, triangle ABC, is of any use to me in solving this one. Okay, so when I see this then, I see 3 sides. I don't have any angles. So this isn't a sine cos tan, okay? So if I go to my log tables, okay, and I look at the tools I have for right angle trig, they're all down the bottom, page 16. I have sine, cos and tan, but I also have Pythagoras' theorem, okay? And Pythagoras' theorem is all about the sides, okay? And we know that because it's written in small letters, okay? It's all written in small letters, and if you have a look at the diagram in your log tables, they have labelled the sides small letters, and they always label the angles with big letters. So Pythagoras' theorem is all about sides. So that's the bit of theory we need for this. Okay, so how does it work? Well, the hypotenuse is equal to, the hypotenuse squared is equal to the other two sides squared, okay? Now, don't worry too much about the x's for now, okay? Or even if you can't do it fully, know that you know Pythagoras' theorem. So know that you know that the hypotenuse squared is equal to the other two sides squared. And you've got the bulk of the marks just for writing down that line, even if you go, God, I don't know where to go from there. Okay, but hopefully you won't be too intimidated by the algebra. Okay, x squared plus x squared is 2x squared. Okay, I need to solve it for x squared. Maybe it's easier if I write it the other way around. I haven't done anything mathematically, I've just literally swapped both sides. Nothing changes sign when everything is swapping sides. Okay, divide both sides by 2. 72. I just did that in my head, but I presume it's right. 72, okay. And then the opposite of squared is square root. The square and the square root cancel. So x is equal to the square root of 72. So as a surd, it's 6 root 2, but as a decimal STD it, you're getting 8.485. It wants 2 decimal places, so my answer, x is equal to 8.5, rounds it up by 1, 0.49. And that's the length of x. Why would it have two x's like this? Well, it's an isosceles triangle. So both sides are the same. So both are 8.49 and 8.49. Can I check my answer? Well, yes. If it's okay with you, I'll do it up here in the red box that I'm drawing above the thing. So I have 8.49 squared. No, let me just undo that for a second now to explain what I'm doing first. I'm checking to see does ac squared plus is c squared equal to a squared plus b squared. So when I do 8.49 squared plus 8.49 squared, do I get the 144 that I had here, the 12 squared? So onto my calculator, I'm going 8.49 squared plus 8.49 squared, and I get 144.1602. Okay, which is a little bit above the 144. That's because we rounded up, so that's correct. Okay, and that ends that question.